Hey everyone, welcome back to the channel. Today we are diving into something really fun. We are going to build a tiny AI neuron in C# that can actually make a decision whether to take someone on a date tonight, whether it's your boyfriend or your girlfriend, or stay home and study. Sounds crazy, right? Well, by the end of this video, you'll understand how a single neuron works, how weights and biases influence decisions, and how you can even scale this to more complex neural networks. We'll go line by line, so whether you are a beginner or an intermediate C# developer, you follow along easily. And I'll even show you live examples of different inputs. See how the neuron behaves. First, let's include the system namespaces. This allows us to use console.writeLine and console.readLine, which are essential for input-output in our programs. Then we define our program class and main method. The main method is the entry point of our application. It's like opening the door to your program's logic. Everything we write inside the main method we execute when the program runs. Think of it as the brain of your application. Next, we'll ask the user for three inputs: weather, energy, and finances. These are the things our neuron will consider when making decisions. Notice we divide by 10. Why? Because neural networks or a neuron usually works best with normalized inputs between 0 and 1. It's like teaching the neuron to understand your rating in its own language. Let's repeat this for energy and finances. Now, our neuron has three inputs. Each input is a piece of information about the user's current state. Imagine a real neuron in your brain receiving signals. This is the computer version of that. So you're going to put your inputs within a scale of 0 to 10. And the neuron will understand this in a manner that 0 is in its worst condition and 10 is in its best condition. Next up, let's assign weights. Weights tell the neuron how important each input is. In this case, finance is the most important factor because 0.9 is the highest weight. And we also know that in real life situation, you cannot take someone out on a date without having some money in your pocket. Think of weights as priorities. If finance is low, maybe the neuron will lean towards staying home. We also have a bias, which is a kind of a baseline adjustment. Bias helps the neuron to make decisions even when all inputs are 0. You can think of it as your natural inclination. If bias is negative, it leans towards staying home. If bias is positive, it leans towards going out. Let's visualize this with a small example. If weather is perfect, close to 10, energy is high. After the input has been normalized, that is, if weather is perfect, 1, energy is high, 1, but finances are poor, 0, the weighted sum will still include the bias, which might pull the decision back towards staying home. Weighted sum calculation. This is how the weighted sum is calculated. The weighted sum is the heart of the neuron decision making. Each input is multiplied by its weight and we add the bias. This gives a single number representing the neural overall opinion. Let's plug in some numbers live and I explain them to you so that we can get a foundational understanding. If weather is equals to 8, energy is equals to 7, and finance is equals to 5. After normalizing them, we normalize so that we can get a figure between 0 and 1. So after we normalize them, we will get 0.8, 0.4 plus 0.7, and then times 0.7 plus 0.5 times 0.9 minus 0.5. So let's calculate. But a raw number isn't enough. We need a probability between 0 and 1. That's where the sigmoid function comes in. Sigmoid squashes any number into a value between 0 and 1. A big positive number approaches 1. A big negative number approaches 0. This is what neurons use to decide how activated are they. Think of it like confidence. If the neuron is 0.9 confident, it's almost certainly saying yes. If it is 0.2 confident, it's almost certain that it will say no. Finally, We let the neuron make a decision based on the output. Anything above 0.5 means a green light. Below 0.5 means to stay home. This is the simplest way to translate probability into a yes/no decision. I'm going to try a few examples and you are going to watch the terminal and see the results that will come out from the neuron. Here are my examples. This tiny neuron is exactly how a real neuron works, because neural networks means you have billions of them interconnected. On a much smaller scale, In real AI, you'd have layers of neurons like this, making complex decisions from recommending movies to detecting face in photos. And this is it. You've just built a C-sharp neuron that can make decisions based on multiple inputs. If you enjoyed this video, hit the subscribe button, comment what decision should we let the neuron make next. And next video, I'll make one using C++.